So here's problem number 3. It's from the 2019 AP Calc A, B, and BC free response sets. It's a question that gives you this graph to work with. Now, I guess I'm going to click ahead as I mentioned a little bit about the graph. So you've got line segment, and they tell you that this part of the graph is a quarter circle that's centered at 5, 3. They do tell us that along this stretch of the graph of f of x, we know the ordered pair 3, 3 minus square root of 5 is on the graph right here. Back in part A, where I already have all the drawing onto the graph done, we're asked to figure out what the value of this definite integral is based on the fact that they tell us the definite integral value from -6 to 5 has to equal 7. So I looked at this integral that they provided us with the answer for, and the integral that they're asking us for the answer for, and I realized that this integral was a portion of the entire signed area represented by this integral, but not all of it. So this integral represents the portion of this one for the stretch of the x-axis from -6 to 2, but I would have to add on the rest of the signed area from -2 to 5 to get an expression involving this that is equivalent to this one. So the integral from -6 to 5 for this function has to equal the integral from -6 to -2, which is the one we're looking for, plus the integral from -2 the rest of the way to 5. So that's just a property of definite integrals that's being applied right there. Now I know what the value of this integral is, so I'm going to go ahead and replace that expression with 7. I want to know the value of this integral, so I'm not going to replace that with anything. And I'm going to have to do a little bit of work to figure out the value of this integral here. I do have the graph of f from -2 to 5 in front of me. And so what I'm going to have to realize is I'm going to have to realize that the definite integral of f of x from -2 to 5 corresponds to the exact signed area between f of x and the x-axis, between this x value and this x value. So I basically just drew a bunch of figures into the coordinate plane here, and I'm working at finding their areas to determine the value of this integral. So this triangle is above the x-axis. Its area is 1/2 base times height. This triangle right here is below the x-axis, also going to have an area of 1/2 base times height. You will notice I subtracted that off because I am below the x-axis. So there's that little signed area component working itself in here. This pink triangle is above the x-axis, so I'm looking at 1/2, 3/2 times 3 for the area of it. And then this space right here is kind of tricky to deal with because I have to be below the semicircle, or excuse me, not semicircle, below the quarter circle, but above the x-axis. So I realized where this circle was centered was 5, 3. So if I drew myself a square right here, 3 units across the x-axis, 3 units up to get to the center of the circle, I have the area of the square is obviously 9 square units, 3 squared, and then I need to subtract off the area of the quarter circle that's right here because I don't want to count that in my integral calculation. So you had to get kind of creative in order to figure out what to do about this little stretch of the graph right there. So I'm looking at 9 minus 1/4 pi radius of the quarter circle squared. Now I do want to solve this for the value of this integral. So I do have to subtract this quantity right here from 7 in order to isolate what I'm looking to find. With a non-calculator AP grading style, you don't have to worry about simplifying. So I can write 7 minus this great big set of parentheses, and that is an acceptable value to list on the AP exam for the value of this integral. I did try to clean it up a little bit. So you'd have to pay attention to what your teacher is asking of you. College Board is going to be fine that once it depends on numbers, you don't have to worry about simplifying. I did take it a little bit further, so I started to try to clean this up a little bit, and I ended up with -4 plus 9 pi by 4 as the value of that integral. You take on risk, you waste time if you go beyond what I mentioned a few seconds ago and try to get this result on the AP exam, though. Part B asks us to evaluate this definite integral. Weird looking definite integral. I right away realized I had two components within the definite integral, and if I broke it up into separate pieces, I might have an easier time managing with what I'm tasked with. So after I broke it up into separate portions, I realized that this portion was going to be pretty simple. The antiderivative of 4 is 4x. I evaluate 4x at 5 at 3 and take a difference, and I end up with 8. So you kind of see that here to this quantity, and then finally to the value of this expression once it's fully simplified. But once again, once I get to something that looks like this, I don't have to waste time. I don't have to take on risk by continuing to simplify that. If it's an AP grading style, don't do what I've done here. If your teacher, your professor's requesting for you to take it to a nice simplified answer, obviously take your time and get it to a nicer value like I have. With this, I realized I could pull the 2 out in front of the definite integral. That's just another property that definite integrals possess. And then if I want to find the value of this definite integral using the fundamental theorem of calculus, antiderivative of f prime is f. I would then have to evaluate f at 5, evaluate f at 3, and take a difference. So you see that carried over right here. Now I can't leave my answer looking like this. I do have to have my answer dependent on numbers and not the function f. So I am going to have to use the graph to find what f of 5 is. Well, f of 5 is 0. I'm going to have to use the graph to find what f of 3 is. Now that's a more difficult task, but they actually provide us with that ordered pair up in the problem statement. I do have to watch out that I'm subtracting f of 3 from 0, so I'm going to have to get that negative distributed in. And if I do everything properly and I simplify properly, I get down to here. But I can leave my final answer as this for the initial portion. Not a great job at underlining there. Let me try highlighter instead. This is the initial portion, plus this is the final portion. That would receive full credit, as would what I have here. But once again, you take on time, you take on risk if you simplify. Part C gives us a new function g. So this function g is dependent on f, and it's defined as a definite integral from -2 up to x. So the variable x on the function g is the upper limit of integration. We're asked to find the absolute maximum value of g on the interval -2 to 5, and then justify your answer. So I was trying to get a lot of the justification out of the way up front. So I'm saying because g is dependent on f, and f is continuous, g is also going to be continuous on the interval from -2 to 5. The extreme value theorem is saying that as long as you're considering a continuous function with which g is, and you're considering it on a closed interval, which we are, -2 to 5, including both endpoints, you're guaranteed to get both a maximum and a minimum. We have our sights set on the maximum here in Part C. And those values are going to have to occur at either the endpoints of the interval or critical numbers within the interval. So critical numbers would be places where your derivative is either undefined or equal to 0. So we do need to know the derivative of g. So the derivative of g is easy to find if you know the fundamental theorem of calculus. Taking the derivative of a function that's defined this way is as simple as copying the integrand from that function and replacing the parameter, the holding variable t, with the upper limit of integration. Now, if there's more than just an x here, you would also have to use a chain rule. Doesn't apply with what we're looking at right now. And then I'm trying to figure out when this is undefined. Well, f is always defined. I have a point on my graph at every single value of x from -2 to 5, from -2 to 5. So I don't have anywhere where f is undefined, where g prime is undefined, but I do need to realize where g prime is equal to 0. So since g prime is equal to f, I need to know when f is equal to 0. Well, f is equal to 0 at this x value right here, and then again at this x value right here. So those x values are -1 and 1/2. Now g prime is equal to 0 again at 5, but I've already got 5 under consideration because it's one of the endpoints of the interval that we're working with. So I need to figure out what g of -2, g of -1, g of 1/2, and g of 5 all are. So I'm plugging those values, -2, -1, 1/2, and 5, I'm plugging those values into the place where the x occurs in g. So when I have the value of g of -2 defined as the integral from -2 to -2, there's no width between those limits of integration. Therefore, there's not going to be any signed area. So that value has got to be 0. G of -1 is going to be the value of the integral from -2 to -1. Well, using arguments similar to what we did back in Part A, That's going to be the area of this triangle right here. 1/2 base times height gives us a value of 1/2. Now, at the x value of 1/2, the signed area between f of x and the x-axis from -2 to 1/2 is going to be this triangle's area, which is going to be positive because it's above the x-axis, and then minus this triangle's area, since that triangle appears below the x-axis. So when you get your dimensions, do your calculations, you end up with -1/4 for that. And then if I'm going for g of 5, we actually already did this calculation back in part A. So we'll go back and check that out real fast. So here's where the integral of f of x from -2 to 5 came into play in part A. It's basically represented within this set of parentheses right here. If you simplify that, and I've got it partially simplified here, but if you fully simplify it, all of these components are going to combine to 11, and then you have this minus 9 pi over 4 component. So it's 11 minus 9 pi over 4. So I brought that to this screen. And which of these is the biggest value? The maximum has to occur at one of them. Biggest of the values that we came up with by a pretty wide margin is g of 5, 11 minus 9 pi over 4. So that is our maximum value. And then in the last part of this, they give us a limit. The limit's kind of crazy. But if you just do what you would normally try initially when you evaluate a limit, and that's replace all of the x's within the limit with what x is approaching, you end up with a 10 for the initial component of the numerator. That's nice. You end up with f prime of 1 times 3 for the second component of the numerator. You do have to realize how to find f prime of 1. Well, this is a graph of f. F prime of 1 is the slope of this graph at 1. So if you do a rise over a run calculation for this stretch of the graph of f, you end up with 2. So that numerator ends up being 10 minus 6 ends up being 4. Again, you can leave it like this right here. You don't even have to turn that into a 4 if you don't want to. In the denominator, we have an f of 1. Well, f of 1 is just the value from the graph of f at 1, which is 1. And then the goofy component here is arctangent of 1, which is the same as inverse tangent of 1. This is something that we don't want to leave dependent on the arctangent function. We do want it dependent on numbers. So we have to try to figure out what arctangent of 1 is. So arctangent of 1 is equal to something. It's not that easy to reason out what inverse tangent values are with the unit circle. It's a lot easier to get rid of the inverse tangent or the arctangent by taking the tangent of both sides of this equation, which leaves us with a 1 on the left. Tangent and arctangent undo each other, and then tangent of some angle on the right. So can we find an angle on the unit circle that's nice and makes the tangent ratio turn out to be 1? Well, since tangent's sine divided by cosine, sine and cosine are going to have the same value. If we have a 45, 45, 90 triangle in the first quadrant right here, and in radians, that 45-degree angle measures pi by 4. So this right here would receive full credit. I did clean it up a little bit, take it a little bit further. Again, you'll receive full credit for that on the AP exam, so don't take on the extra risk, don't take on the extra time. Leave your answer like that, or pay attention to what your teacher's asking of you if they are requesting for you to go to the finish line like I have here.